Yes, we are back. We join our regularly scheduled program already in progress. Okay, so to be fair, my morning class was first block after a 4-day weekend. There was a little bit less comprehension than I was hoping for. So we will see what happens today. Now, you have been given many ways to graph lines. The way you got in grade 9, table of values, always works. But it can be a pain in the butt, especially when the x's and y's are on the same side of the equation. That makes it difficult. But fortunately, you've been given a couple of other ways with which to graph an equation without actually making a table of values. You can just look at the equation and know it. The first method that allows you to do that is slope-intercept form. And slope-intercept form, as you all remember from reading in your notes, is y equals mx plus b. And when that comes up, you will notice that what is highlighted in yellow shares some characteristics with what is highlighted in blue. What are those characteristics? This is like a pie-in-the-face question for Miss Craig, because I'm bringing in English to math class. What are the characteristics of the yellow highlighted equation and the characteristics of the blue highlighted equation? Think of a Venn diagram. What do they share? What do they not share? Pardon me, Louis?
An X and a Y.
They have an X and a Y. Excellent. What else do they share? What else do they share? What else do they share? Yes, grossly.
The slope is 2.
The slope is not 2. I will ask again. Just answer the question asked. Do not overthink. Do not try to play lawyer ball. What else is the same between that and that?
There's a plus sign.
Excellent. There's some math involved. Good. Keep going.
There's equal sign too.
Yes, excellent. They're both equations. Good. Keep going. Okay, I'll try highlighting the single things and see if that helps us. I'm not sure it will, but I'm going to do my best. What else do they share? They both, X both has a coefficient. Excellent. What else do they share? A single number, a constant. Lovely. Now that we have done the middle of the Venn diagram, let's talk about what's different. What is different between the two? I'll re-highlight the whole equation again and see if maybe you guys can come up with this on your own. Corey.
This time the Y is on the inside, the other is on the other side.
Okay, it does have to do with the Y. What is the difference in the Y? One has a coefficient, one does not. That is a difference. Excellent. Is there any other difference? Carl. Y is isolated. All right, good. That was adequate. Almost. Let's try and get all the way up to adequacy, shall we? What is that value in this form? That is the slope, which is, of course, the rise over the run. What is that value in this form? The y-intercept. So to graph it, you would go to that point and count the rise over run, make another dot and connect them, right? Okay. Would we need a table of values if we were in that form? No, because you know one point to start and you know how to count rise over run to get to a second point and a third point, right? So if we can make the blue thing look like the yellow thing, we can graph this without using a table of values. So what do we have to do? We have to look at the things that are different. 1, y was isolated. 2, y had no coefficient. There's actually a third thing about y that's important. What do you notice is missing from in front of this y? There's no coefficient and there is no something else. What else could go in front of that y that would change its value? A negative. So y must be isolated, y must be positive. If y is isolated and positive, then I automatically know the slope and the y-intercept. All right? Okay. Ethan and Serena, I'm just going to pause this. If I can make the blue equation look like the yellow equation, I will be in business. So, since y must be both isolated and positive, let's look at the situation we have for y right now. Is it either isolated or positive? It is positive right now. So I better not do anything to it. I better not move it around, because if I move it, it will become negative. So we're going to leave y right there. So how then do I isolate it? Isolation means it's got to be by itself, so I better move some stuff. How do I move positive 2 x's? I am not trying to get rid of the 2, I am trying to get rid of the whole thing. So what do? I take away 2 x's. Where else? On the other side. So now I have 3y minus 4 equals negative 2x. Now hopefully you have all seen this trick at one point in your math life. If you move anything over an equal sign, you change its sign. That is a very important and powerful shortcut to use. We have not changed the equation, we have just changed what it looks like. It's kind of like putting it in a suit and tie and making you think that it's actually classy when it's not. Okay? Okay. What else needs to move? The 4. If it moves over here, what happens to its sign? It becomes positive. So now I have 3y equals negative 2x plus 4. Is y isolated? Almost. I don't want to move the y now. I only want to move the times 3. So what do? Divide by 3. And I get y equals negative 2/3 x plus 4/3. Does that now look like the yellow one? One part of that should scare you. Well, I lie. It shouldn't scare you, but it does scare you. Which part of that scares you? The fraction. Which fraction? Because there's 2 fractions. The negative 2/3 is what scares you? That's the slope. Slope is rise over run. So I'm just asking, should it scare you? No. What's the other fraction? That should be a little scary. Why? What has b been in every other case we've done? It's been a whole number. It's not now, is it? Why shouldn't it scare you? Because you can change the scale. Since we're in thirds here, where should I put my number 1 on the graph for my y-axis? Should I put a 1 there? Why?
Because it's 1/3, so it's not a whole number.
It's not a whole number. So what if I went up 1, 2, 3 and put my 1 there? Now is it easy?
Yeah.
Why? Fractions in thirds, and I need 4 of them, yes? So where does my y-intercept happen? On the 4th line. Everybody understand? Now, am I able to keep that scale on the x-axis? I am indeed, right? So 1, 2, 3, 1. Now I need a slope of negative 2/3. Since these squares are the exact same value, can I just count in this case? Yes. Where do I count from my y-intercept to graph this line? I must use the slope. You have written it down. The slope is negative 2/3. How do I transfer that slope from algebra, negative 2/3 x, to a graph? I go down 1, 2. There's the negative 2. And I go right 1, 2, 3. There's the positive 3. How do I make sure I have done it properly? I go back to the start and I do what? I do it again. Do I do the same way? No. I go up 1, 2. There's the positive part of it. And I go left 1, 2, 3. There's the negative part of it. And then I connect my line. Yeah? Yeah. What is different in number 2? I've forced you to use another method, yes? What is that other method? It uses x and y intercepts. Do I know something about every single x and y intercept? What do I know about them? Right. For the x-intercept, it's always x comma 0. And for the y-intercept, what is it always? 0 comma y. That is an x-coordinate, that is a y-coordinate, that is an x-coordinate, that is a y-coordinate. What do you see there and there? X's and Y's. If you do not understand the step that I'm about to do, you are going to be incredibly challenged by the rest of the year. Not this unit, the rest of the year. And all of grade 11, in whichever stream you go. And all of grade 12, in whatever stream you go. And in all of university, wherever you end up, if you cannot follow what I am about to do. That x is an x value. What is that right there? An x. So I can write 5x. That is a y value. What do I see right there?
A 0.
So minus 10 times 0 plus 15 equals 0. 10 times 0 disappears. 5x plus 15 equals 0. I still need a value for x, so now I must do algebra. All of you should, of course, already have this done. X equals negative 3. This is the next important step that if you cannot follow this, you are in dire circumstances. X equals negative 3. Is there anywhere on my page that you see an unknown x? Right there. X equals negative 3. So I have a point at negative 3, 0. Should I put that on the graph now?
No.
Why not? I need to know what y is, because if y is a fraction, I might need to change the scale. Let us see, cabbages. Y is 5. What's that x value now?
0.
0. 5. That's supposed to be red because I'm doing the y-intercept. 5 times 0 minus 10y plus 15 equals 0. That drops out. Negative 10y plus 15 equals 0. Negative 10y equals negative 15. Y equals 1.5. There is a y and an equal sign. Is there an unknown y on the page?
Yes.
1.5. So now I also have a point at 0, 1.5. Now, do I need to change my scale?
You could do 0.5.
You could do 0.5, but this is a very tiny graph. It's hard to find halfway between, isn't it? But it's easy if we change the scale, correct? Which scale needs to change? The y values. So if I go up by halves, I'll be fine, won't I? 1, 2. So where's the y-intercept? Right between them. Right there. Now, since I've made 2 squares worth 1, can I fit the x-intercept on this graph? Where will I need to go? How many squares left or right? I will need to go how many? Left, 6. 1, 2, 3, 4, 5, 6. It does indeed fit. And since I've already shown the scale there, I show the scale there, 1, and I can connect my line. Is everybody good? All right. Now, let me ask you this. They had the same scale, correct? So can I count slope on the graph? Yes. 1, 2, 3, 4 up. 1, 2, rise. 1, 2, 3 up, 3. And that way, 6. So slope works. What if this scale was different? Could I count? No, I would have to go by value. Does everybody understand? Okay. Next, how do I find that slope? Oh, I have a question first. Pretend we did not graph that line. It's not graphed. I would like for you to tell me if 4, 7 will be on that line. How do we do that? This is not a question that was on your paper. I'm seeing if you're following the concepts. What do you know about 4, 7? It's an X and a Y. What do you see there and there? So what would you do? Sub in 5 times 4 minus 10 times 7 plus 15. What's 5 times 4? Minus 10 times 7 plus 15 equals 0. Does it? No. Negative 35 does not equal 0. So is that going to be on the line? No. Everybody understand?
Yes.
Good. Number 3. How do I find slope without a graph?
y2 minus y1.
Who decides?
Us.
Which one is y2? 4? Sure. y2. Which makes 2 what? x2. Which makes 3 what?
x1.
y1. Which makes 10 what?
x1.
And pretty soon that will all show up.
Pretty soon.
Well, you know, after a certain amount of time. There it all is. And then we just fill it in. Notice once again, we are simply substituting values that we know that are all what? X's and Y's. That's all we're doing. 4 minus 3 over 2 minus what?
Minus 10.
Negative 10. Hey, Eric, what's 2 minus negative 10?
12.
1/12 is the slope. If you had a pie, you could pie me.
I wish I did.
Do you really? That's hurtful.
I like throwing pies in people's faces as well. Especially if that's
Number 4 caused a lot of grief in other situations. Slope and parallel. I want to know the slope of a parallel line. What do we know about parallel slopes? They're the same. So I have this line right here, this yellow line, has a slope, doesn't it? Any parallel line will have the same slope, won't it? How can I know the slope of an equation just by looking at it? What would I have to do? If it looks like this, do I automatically know the slope? Yes. So if I isolate y, I automatically know the slope, don't I? Do I even need to care about this number? No, because I want a different line, don't I? I don't want the line that goes through that. I want a different line, as long as it has the same slope. So all I care about is the x's and y's. What would I have to do to isolate y and make it positive? I would move the y. 5x would equal positive 3y. Now I know I don't need to care about the 12. Now what would I do to get y by itself? So 5/3 x. What's the slope of this yellow line? 5/3. 5 over 3. Rise 5, run 3. So what is the slope of every parallel line? 5 over 3. So as long as I have y equals 5 over 3 plus x plus any other number, is that line going to be parallel to this line? Yes. But all I cared about was slope. So the answer, all I needed was 5/3. Everybody good? Great. How many people didn't do number 5? And when I say didn't do it, I mean you tried the rest of it. I'm not saying you did nothing on the page. If you tried the rest of it, how many people left number 5 alone? Why? Something freaked you out about it, right? What freaked you out about it? What about 5 is different from 4? Because if you understand 4, 5 is pretty simple, right? It doesn't have to be parallel, it's got to be perpendicular. So what does that mean the slope has to be?
Oh, it's a dinosaur?
So, if I know this slope, what would I do to find the slope of a perpendicular line? Flip it and change the sign. Find this slope. 7x plus 2y. We don't care about the 10. Get y isolated. What moves? 7x. 2y equals what? Negative 7x. Now what? Divide by 2. Y equals negative 7 halves x. That's his slope. What slope do I need? I need m equals what? 2/7. Flip it, change the sign. Number 6 is the hardest question you have done yet. A great many of you won't have tried number 6. A great many of you will have tried number 6 and maybe gotten it wrong. A great many of you will have no idea how to start. I will ask you this. What is that? That's an X. What is that? That's a Y. What is that? So that's an M. Have we done any work with something that has X's, Y's, and M's? Dead silence. Pardon? Y equals mx plus b.
Oh, we did do that.
What can I write for y?
-2.
-2. What can I write for m?
2 over 3.
-2/3. What can I write for x? -5 plus b. Correct? Everyone agree? Okay. I should probably know what b is, shouldn't I?
Yeah, I think that would be helpful.
Well, let's try. -2. What is -5 times -2? Positive 10 over what? 3 plus b, correct? 10 over 3 is 3 1/3, isn't it? How do I get rid of 3 1/3? I put it over here, don't I? So what is -2 minus 3? -5. Take away another third. -5 1/3 equals b, correct? Is there anywhere on the screen that you see an unknown b? Right there, correct? So that gets me y equals -2/3 x minus 5 1/3, correct? Now, I need any other point. Every other point on the whole universe is in what form? Every point in the whole universe has what form? X, comma, y. Which of those is input?
X.
What's the easiest input to do? 0. What is -2/3 times 0? 0. What is 0 minus 5 and 1/3? Negative 5 and 1/3. So when x is 0, what's y? Negative 5 and 1/3. Is that another point on the line?
Yeah.
Easy peasy lemon squeezy. Did you need any piece of new skill to solve that? Nope. You need to know one thing, that b is the y-intercept. And even that you didn't need to know. As long as you knew that, you should have been able to figure this out. And finally, I want to know if that's a right triangle. If it's a right triangle, two lines are going to meet at what angle? 90 degrees, which means they are what? Perpendicular, which means their slopes are what? Opposite reciprocals. Do you want to check all three corners? I don't. How do I make it so I only have to check one corner? How do you eliminate some of the corners? Starts with a S, ends with an H, has Ketka in the middle of it.
Sketch?
Sketch the graph.
Did I actually do it right?
Yes. Where is 4, negative 2? He waited patiently. Right. 1, 2, 3, 4. And down. 1, 2. There's A. Where's B? Right. 1, 2. Up 1. Where's C? Left. 1, 2. Down. 1, 2. And then you connect the dots. Where is the only possible 90 degree? Right there. You can find the slope in how many ways? He waited patiently for his class of 30 to say one thing they could do to find a slope.
Rise over run.
Excellent. You could do rise over run. So you could go from C up to B. B is at 1. C is at negative 2. So that's up 3. And that way, how far? 4. So that's a slope of 3/4, correct? Then we could check B to A, which is up how far? 3. And that way, how far? 2. Are those negative? Negative 3. Are those reciprocals?
No.
So is it a 90 degree triangle? No. No. How else could I find it? I could do the slope of CB, and I could compare it to the slope of BA. And slope is, of course, y2 over y1, right? Or y2 minus y1. So CB would be negative 2 minus 1 over negative 2 minus 2, which is negative 3 over negative 4, which is 3/4, which we already knew from counting. Then I would check BA, which is 1 plus 2 over 2 plus 4. Sorry, 2 minus 4, which is 3 over negative 2. Not reciprocals, not right angled. Everybody good? I hope so, because like I say, what we're going to do next really needs you to be good at this stuff. Turn your page over. This will not take long, and then we will go over the test. If I wanted you to graph a linear function, you now have 3 ways to do it. What's the first way you learned in the 9th grade? What is the 3 ways? I have an equation. A table of values is the first way. Table of values, which I'm going to put right here in green. Keep it green. X, Y. What do you do for a table of values? If you have an equation, you choose which? X's or Y's? X's. Why? You had a 50-50 shot. Why do we choose our X's? Starts with an input or an output? You start with an input. X's are our inputs. Excellent. What is the easiest input to use? 0. So you would start with 0 and then you would sub it in and that would get you a Y value, correct? Everyone agree? Cool. What's the second way I taught you to do these? The first thing in this unit, to graph a line. What did I say to use? Not quite. That's the third thing. Very first thing we did in this unit. X and Y intercepts. X and Y intercepts. Which are what? X comma 0 and 0 comma Y. And you sub them into the equation. Everyone agree? And the last way, Seamus just said it, what was it? We use the slope intercept, which is number 3, y equals mx plus b. We go to b and count, what was it again, Seamus? And count rise over run. Yeah? Everyone can do all 3 of those, right?
Sure.
Now, what is the same in all 3 methods that you already know? Eric.
X's and Y's.
X's and Y's. Is there anything specific about those X's and Y's that we used in all 3?
There's got to be something specific about it.
Yeah, there is something specific. What did you use there? X was 0, which means it's what? The X what? When X is 0, what do you have? The Y-intercept. So you use the Y-intercept here. What did you use here? Y and X intercepts. What did you use here? What's B? The Y-intercept. So all 3 of those methods, we have to know an intercept, don't we? Look at the name of today's lesson. Point, slope, form. Does it say anything about intercepts? Point, slope. This method will allow us to use any point to graph. And this is what it looks like. It looks a little bit scary, right? Is it? Does this look okay?
Sure.
What about it looks okay? What about it you're like, oh, I can deal with that? Eric? It's got X's and Y's and what else? An M. We know how to deal with X's and Y's and an M, don't we? All right, now, here's where you must pay close attention. The blue points are the unknown point. The green X's and Y's are the known point. All right? So, if I were to tell you, graph a line from 5, 7 with a slope of 1 over 2. Could you do it? Let's see. What do you know about that? That is what? A point on the graph, is it an X or a Y? That's an X. What do you know about that? It's a Y. Do you know on the graph where 5, 7 is? So is that a known or unknown point? That's a known point, which means it would go where? Where the green is or where the blue is? Where the green is. So the point, the equation would look like this. Y minus what? 7, because it's a Y value, equals, what goes in for M? 1/2, bracket, then what? X minus 5. Everybody cool? Right? XY, since it's a known point, it goes in the known point spot. Everybody good? Yeah? Okay. Watch. What if I then changed it to not 5 and 7? I changed it to -3 and 2. What would my equation change to? Y minus 2 equals 1/2 X minus -3, which would be what? 1/2 X plus 3. Correct? Everybody cool? What if I changed it to -2, -4? Then what would it be? Y plus 4 equals 1/2 X minus 2. All right. And what if I changed it to -3, -7? Y plus 7 would equal 1/2 X plus 3. Now, all of you should notice something. If you have the known point, what happens to it when you put it into the equation? Because our first point, you'll remember, was -5, 7. Now you've got all the color coding there. It changes sign. Right? So what then, using your logic and your intelligence, if I wanted you to graph this, what point would you start at on the graph? -4, 3. Who said it? You would start at -4, 3. And how far would you count up?
3.
Up 3. And then what direction?
Right 4.
Right 4. Would it be right 4 or left 4?
Left 4.
The slope is positive 3/4. So I must go up 3, that's positive, and
Is it right positive?
so I go up 3 and right 4, which most people said at the beginning. Then a few people started going left 4, left 4. It's not left 4. They're both positive. Is everybody cool? Now, I want to show you why this works. You don't need to write down anything more now because this is all you need to know. But I want to show you why it works. Somebody give me a number between 1 and 10.
7.
Give me a fraction.
5/4.
Give me another number between 0 and -10.
-5.
Now, why is it that those are our known points? Right? If those are our known points, the reason they are our known points is because, watch, we know that this needs to be opposite on the graph, correct? Which means the actual point on the graph would be -5, +7, wouldn't it? Is that an x? So I would write it right there, wouldn't I? -5. Is that a y? Yes? So I would write it right there, wouldn't I? What's 7 minus 7? 0 equals 2/5. What's -5 plus 5? 0. That is why our known points, we have to reverse the sign. Does everybody understand? Okay, let's see if you really do. Tell me the starting point and the slope of this first one. Where would I start? Talk to your neighbors, look at your notes. I'm going to look up on the count of 3, and I'm going to hope I see a hand or two. 3, 2, 1. Okay. Eric, you can go first.
Oh, I don't know the answer. I just want to raise a hand.
Seamus. No, Liam.
1 minus 2.
Oh. No, he's right. 1 minus 2. I was messing with you. And a slope of? Up to left 3 or down to right 3. Nice! Who's doing the second one for me? Where do I start?
-3 causes 4.
And then? Up 1, left 4 or? Down 1, right 4. And it's not the smell of rotting milk. It's tears of joy. What do I do for number 3? Start at -2, -1. What's my slope? Up 1, right 1, or
Down 1, left 1.
holy crap.
We're going for gold, boys.
I'm scared. I don't know what I'll do if we get all 6 of them. Where do I start here?
Start at
-4.
Yeah, and then
up 1.
up 1
Right 2.
or
Down 1, left 2, my dude.
oh wow.
You got to write my dude.
Number 5, where do I start?
-5.
And
Right 1. I know. So then you left 1, right?
or
Down 1, right 1.
and finally
1, 10, up 4. No, you're not. Right 5. Change this up.
or
Down 4 and 5. Good job, my boys. Let's do this.
unheralded. A slow clap is most definitely in order. All right. Now, prove it. Where do you start? Where's -1, 2?
1 to the left, down, up.
1 to the left, up 2. What's my slope?
Up 2, right 3.
Up 2, right 3. Everyone agree?
Yes, sir.
Now, how many points should I get to make sure? 3. So where I go back to the start and then I do what?
Down 2, left 3.
Everyone agree? Now, what are the coordinates of that dot. 2, 4, correct? What are the coordinates of that dot? No. -4, 0. Does everyone agree? Everyone agrees? That is what value in X or Y? 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 That is what value? X. Y minus, not Y. Y minus 2. 4 minus 2, correct? Equals 2/3 bracket. What's the X value? We're working with the purple one. I should have done this in purple. 4 minus 2 equals 2/3. 2 plus 1, correct? What is 4 minus 2? 2. What is 2 plus 1? 3. What happens with the 3's here? They cancel. Does 2 equal 2? So is that point on the line? Did we graph it correctly? Yes. Now we'll work in pink or dusty rose. What do I write? 0 minus 2, because that's a Y value, equals 2/3. What? -4 plus 1. What's 0 minus 2? -2. What's -4 plus 1? What do I do with the 3's? Cancel. -2. Does -2 equal -2? So is that point correct? Everyone see how it works? Prove it. Do 8.
The answer is 4.
Where do I start?
Right there. Oh, -5.
-5.
-1.
Where's that?
And left.
Left 5, down 1.
There you go.
Then what?
You got your 2 over 1.
Right? So it's
-2 over 1.
up or down first.
Down.
Down how far?
2.
And then right 1. 1, 2. And or
Up 2, left 1.
everyone agree?
Yes, sir.
Okay, what are those coordinates? I'll use purple and dusty rose again. What is this guy? -6, 1, and what's this guy? -4, -3, correct? So, in purple, what do I write? Remember, X's and Y's. So what do I write first? 1 plus 1, which is what? While we wait for my computer to thaw.
3.
1 plus 1 equals -2 bracket -6 plus 5. What's 1 plus 1? 2 equals -2. What's -6 plus 5? -1. What's -2 times -1? +2. Does 2 equal 2? So is that point right? Excellent. Now we check the dusty rose point. What do I write? -3 plus 1 equals -2 bracket -4 plus 5. What's -3 plus 1? Negative 2 equals negative 2. What's negative 4 plus 5? 1. What's negative 2 times 1? Does negative 2 equal negative 2? So is our Dusty Rose point right? Excellent.
Wow.
Please notice that all we did was go to the point we started from, and then we were able to put in the x's and y's. What if I went up 12 and left 6? Would that point work?
Yeah.
Why?
Because it's 1 over 2.
2 over 1. But yeah. What if I went down 18, and how far right would I need to go? 9. Everybody understand?
Yes.
Good. Now, look at number 9. What are some of the hint words in number 9?
Perpendicular.
Perpendicular is a hint. How many lines do I need? 2 of them. So I'm going to have 2 lines that cross at 90 degrees, right?
Yes.
What else do I know about those lines?
1 minus 2x.
Pardon me, where do they cross, Justin? On the y-axis. So that means those lines must have the exact same y-intercept, correct? So we know that. And I know one of the lines. Can I use that to find my y-intercept?
Yeah.
How? What would I have to do to that to know my y-intercept?
Algebra.
Right? And make it look like what, Eric?
You put the y on one side.
Get the y by itself. If I move that y, do I have it? 2x plus 8 equals y. Do I now know my y-intercept? Yep, it's 8. 1, 2, 3, 4, 5, 6, 7, 8. Do I know the slope?
2 over 1.
Positive 2 over 1, right?
Yeah.
So down 8. How far out here?
4.
4. Nice. There's one slope, correct?
Yes.
That is my blue line. What do I know about the other line? Where does it go?
It has the same y thing.
It goes through there with what slope?
The same slope.
The same slope?
Opposite slope.
They're perpendicular. So what do I do?
I don't know.
Somebody tell Eric what I do with the perpendicular slope.
Somebody told me, I don't remember.
Did the opposite.
I get the opposite and...
The negative?
No, the negative covers the opposite. Opposite means you change the sign. What else do I do? Reciprocate it. So if my original slope was 2 over 1, what's my perpendicular slope? Perpendicular was what? Negative 1 over 2. Is that my slope? Do I have the same y-intercept?
Sure.
So write out the formula. Y equals mx plus b. What goes in for m? Negative 1/2. What goes in for b? Positive 8. Can you put it in point slope form? Do you know that value right there? What is it? Negative 4, 0. So point slope form would be y plus 0 equals what? 2x plus 4. That would be line 1, the original line, right? And what would line 2 be? It would be y minus y1 would equal not 2. What would it be? Negative 1/2 x minus x1. But I don't know those two, do I? Or do I? What's my y-intercept? 8. I need a slope of negative 1/2, right? So if I go down 4, how far out would I have to go?
2.
Other way around. I need it to be negative 1/2. Rise was 4, so my run would have to be 8, right? So I'd be out here, and it would be y plus 4 half x minus 8.
That makes a lot of sense, actually.
Bye, Mr. Myers.
Bye-bye.